السلام عليكم يعطيكم العافية. Continue section 16.7. Now this is the last question in this. This is the last problem in this section. Okay, so let's first read the question. So at the given instant, member AB, this is member AB, has an angular motions. So you can see from the drawing that this is the alpha angular acceleration and this is angular velocity shown. Determine the velocity and acceleration of the slider block C at this instant. So we need to find out VC as well as AC, and I think I have final answer. Okay, so since the units in inch, I'll stick to the inch as it's written here in the answer. Now let's move to the solution board. Here it is. So let me first start with drawing the first link from the most common information link. So this is joint A and here we have joint B. Okay, and this link has known alpha and omega. That's right. And this. Okay. Now let's figure out first the velocity of point B. So VB equal VA plus VB with respect to A. VA 0 plus, instead of the relative velocity, we'll write omega cross product RB with respect to A, and this is equal to omega, well known, which is equal to 3. First of all, I forgot to write the positive directions and rotation. So omega given, which is 3 rad per second, this is 3 in positive k direction, cross product 7 in the positive j direction. And the answer is minus 3 multiplied by 7, this is 21 in the I direction. And one can tell from the beginning that if A is constant, if A is fixed, and this link vertical and rotate counterclockwise, then point B with velocity in one direction. Let me go back to the PowerPoint presentation to show it to you. Then if this is rotate counterclockwise and this is vertical, then VB will move in the negative I direction, and the answer was negative 21 in the I direction. Okay. How about C? C sliding in this point. So point C in this direction. So it will has velocity in negative j direction and velocity negative I direction. This is x and here this is y. Okay, this is our expectation and it should be correct. Now let's see the acceleration. So I will finish one by one. So I will finish everything related to same link, then I'll move to the other link. So AB would equal to AA plus AB with respect to A tangential plus AB with respect to A normal. This is equal. Acceleration of point A, which is fixed, equal to 0, plus Relative acceleration in tangential, this is alpha cross product RB with respect to A minus omega squared RB with respect to A. Okay. Equal. Alpha rotates counterclockwise and its magnitude is 2, then this is 2, then this is 2 cross product or 2 in positive k direction cross product RB with respect to A, same as we did earlier with the velocity, then this is 7 inch in positive j direction minus omega equal to 3 squared dot product 7j. And the answer is, this is acceleration v. So k cross product j, this is minus I minus 14 I. This is the first component in the negative I direction. And here 3 squared, 9 multiplied by 7, this is 63 in j direction. Okay, and again you can easily tell that point B if it is rotate like this has tangential acceleration AB tangential in the negative I and normal component in the negative I direction. Okay, so our answer is correct. But keep in mind that this answer, its unit is inch per second squared. The same for the velocity. So velocity here, inch per second. This is velocity. Okay. So that's it for link AB. Now let's see another link. Now link BC. Here we have B, and this is C. Oops. Here we have C. Now the vertical direction, this is vertical direction. You go back to PowerPoint presentation. Vertical direction 7 plus 5, which is 12, and the horizontal direction 5. So 12, and here we have 5. I care about point C, then I'll start with the velocity equation. Vc equal to Vb plus Vc with respect to V. Then Vb, already we find it in the previous link, and it was minus 21 in the I direction. Okay, this is minus 21 plus Vc with respect to B, this is omega, and we should assume that this is the direction for alpha as well as for omega. This is assumption. If it is wrong, then we will modify it. Okay. Okay. Then this is omega in k direction cross product. Now I'll travel from B to C, then I'll go downward from B in the I in the j direction. So this is minus 12 in the j direction. Then I'll move to the left, minus 5 in the I direction. Now BC equal to minus 21 in the I direction plus, so keep in mind that BC is unknown as well as omega is unknown. So omega k direction cross product j minus with minus positive, so this is 12 omega in the I direction. Now k cross product I, this is positive and we have negative, then this is minus 5 omega in the j direction. Now if I go back to the question, you can notice that BC, as we mentioned earlier, has two components. This is BC in x direction, which is equal to BC sine theta, and this component this is Vy. Okay, this is V. Sorry, this is Vy. And here we have VC in the x direction, and this is equal VC sine theta. But why I write sine theta, cosine theta like this? Because here is the angle. This is the angle I care about. Okay, so this sine theta, if I take a look to this triangle, sine theta equal to 4 over 5, and this is equal to 0.8. And this one equal to sine theta equal to 3 over 5, and this is equal to 0.6. As a result, VC has two components, one in the negative x direction, and this is equal minus 0.8 VC in I direction, this one, plus or minus the other component, which is 0.6 VC. So this is minus 0.6 VC and the J component. So what's the benefit? The benefit will appear here. So instead of VC, I will write VC, I will write minus 0.8 VC in I direction, minus 0.6 VC in J direction. And I will continue the rest of the equation as is. So if you take a look, then we have I equation and J equation, and we have two unknown. If you solve them, so let me go to new page. If you solve them, you will find out that omega equal to omega BC, the length, equal to 1.125 rad per second, and VC equal to 9.375 inch per second. This is the velocity equation. Why we solve velocity equation? Because while we solving, because we need this velocity. Okay, it's mentioned in the question that this is needed. So if you'd like, we can check the final answer. The final answer is 9.375, which is correct. Now let's move to the acceleration equation. So acceleration equation AC equal AB plus tangential component, which is alpha BC cross product R C with respect to B, okay, minus omega BC squared dot product R C with respect to B. AC again, we'll write it in both component, okay, as we did earlier with the velocity. So minus 0.8 AC in the I direction, minus 0.6 AC in the J component. This is AC. Equal AB, we found it from the previous link, which is equal to, as I remember, minus 14 in the I direction, minus 63 in the J direction, plus alpha, which is, we assume it in the positive K direction, cross product, relative position vector as before, as in the velocity equation, minus 12 J component. Now omega 1.125 squared, we find it previously, dot product same, as before. Now we have one equation. This is the equation. Here is our equation. How many unknowns we have? We have two unknown, AC, it's mentioned here and there, and we have alpha is another unknown. So one or two equation ij with two unknowns, we can solve them. So I leave the solution for you as a practice. So we'll discuss on this if you have any trouble later on. So you will find the answer will be alpha equal minus 3 rad per second squared, minus it means in the opposite direction, and acceleration for point C will equal to 40 or 54.7 inch per second squared. And this is the resultant acceleration in the direction of the channel, or the direction of the slide. So that's it for this section. Now section 16.8 I leave until we will come back from this emergency vacation. Okay. Now next lecture we'll move to a new chapter, which is chapter 17. Bye bye.